Hello everyone, this is Xiuqi Huang from Visionox. First of all, we'd like to thank OLED-Info for giving us this opportunity to present our thinking about OLED display technology. Visionox was established on the foundation of OLED technology developed at Tsinghua University in China. Until now, Visionox has become the leader in the OLED industry in mainland China, successfully integrated the state-of-the-art R&D, mass production, with marketing and sales. In this presentation, we'd like to take this opportunity to present our understanding of OLED display and its technology challenge. We'll also take some time to introduce our Visionox OLED project. Finally, a summary will be given. So, let's move to the first part. Why OLED display? Before we get the answer, let's raise another question first. What is display? It is pretty simple, but not easy to answer. If we try to get a definition through the internet, it could be to transfer information through visual perception of human beings. Well, there will be two key points: transfer information and human beings. Okay, let's get back to the history of display to check out how we transferred information in the past. Actually, before 1900, we can call it pre-electronic era. In ancient times, we only had this for display: oracle, paper slip, ancient painting, and photograph. The point here is the information transferred was fixed. As time passes by, we had watch, wire electricity meter, and film. The information became variable. Then, during the last century, we entered into the electronic era. Like the mobile device, PC, and TV, display offered information more than ever before. And then, here comes the internet era. Now we have smartphone, wearable device, and even remote healthcare. You can find that the most important feature is interactive. Instead of passively receiving information, people like to have more interaction with others, whether it's a guy or a machine. Well, the future. Of course, nobody can be sure about what will happen. But more likely, we need to take the holographic display, virtual reality, and augmented reality into consideration. So, when we look at the developing chain of display from classical to current and even future, we can figure out that the quantity and the quality of the information transferred are on the way to being improved. Well, there's another keyword of talking about display. Since we all know display is always related with human, it can be classified into three categories. Between human and objects, people always care about accuracy and speed to acquire information. Between human and circumstance, display should supply the interactive experience such as virtual reality and malleable sensibility. For the communication between human and human, we need to overcome the barrier of time and space. These are what we have now, and the future has already been shown in the movie. Anyway, display shall be human-oriented, and it always needs to satisfy the human need of pursuing freedom. Now, let's come back to the original question. What is display? We realize that the development chain of display is not only to transfer information with larger quantity and higher quality, but also to meet the human nature to chase freedom. In a word, anytime, anywhere, display can show you anything. Okay, let's focus on recent development of electronic display. In the last 2 decades, display changed from CRT to flat panel display. When we talk about CRT, everyone may feel like it is cubic, it is huge and heavy. However, for LPD, it is flat, thin, and light. But let's see what problem it solved. For CRT, it increased information density a lot, which makes the display much more colorful. For LPD, the most important thing is its position can be changed as requested. In other words, we can say that LPD makes the display portable. But still, the design of product is strongly limited because the shape of panel is fixed. These days, people are talking about flexible display a lot. Of course, the flexible display can be ultra thin and light. But more importantly, the size or shape of the display can be variable. Definitely, it will provide much more freedom for both the designers and users. Flexible display can be potentially applied to lots of regions, like TV, mobile phone, mobile computing, wearable device, vehicle, e-paper, and electronic board. And it will give us plenty of space for imagination and generate a totally new market. But why OLED? Let's see what flexible display needs. Because it needs to be flexible, it shall be thin and light, have wide viewing angle, and its mechanical stability must be very good. Let's see what OLED can provide. Since it uses organic material, of course it can be thin and light. It is self-emitting, so viewing angle is not a problem. And because it is non-crystal, the mechanical stability can be good. So, maybe OLED can be the perfect choice for flexible display. Now let's go back to check the technology for electronic display. For CRT, of course it shall be CRT. For LPD, TFT LCD and OLED are currently playing the role. For flexible display, it looks like only OLED will make it. You can see that OLED technology can cover both LPD and flexible display. Apart from this, OLED display also has other features which make it more important. Scientifically, OLED display needs different knowledge from various subjects, including material, chemistry, semiconductor physics, microelectronics, and optoelectronics. In addition, OLED display industry is a very good integration of upstream and downstream industry trade, such as material, driving IC, process equipment, touch panel, and industrial design. We can say that it is not only interdisciplinary, but also has a very strong industrial driving capability. Therefore, it can provide a platform to combine science and industry, from fundamental research to mass production. Next, let's talk about the technology challenge of OLED display. So first of all, what is OLED? Generally, OLED is an organic light emitting diode, which the emissive electroluminescent layer is a film of organic compound which emits light in response to an electric current. According to different driving modes, OLED includes PMOLED and AMOLED. In simple terms, PMOLED is driven by external IC and its pixel is lightened by sequential scanning and keeps a very high refresh rate, resulting in a relatively low resolution. For AMOLED, each pixel has internal storage capacity so that it can keep its luminance and to updated by next frame sequential signal from external circuits. Therefore, AMOLED display can reach high resolution and large size. It also requires a complicated backplane and the cost is much higher. Basically, the development of OLED luminescence has passed 3 stages. The first one is the OLED material, in which people do lots of fundamental research on characteristic. The second is OLED device, in which the device function has been achieved. The third is the product for application. which people always care about in mass production. Nowadays, the mainstream of OLED display is AMOLED. There are various demands on AMOLED panel, such as large size, ultra-thin and light, high resolution, integrated touch panel, and so on. But from the technical point of view, AMOLED technology always consists of three parts: TFT backplane, OLED device, and driving circuit. Okay, let's take a look at them in a little bit of detail. The functionality of TFT backplane is to drive the OLED device. Based on the TFT channel semiconductor material, TFT backplane includes ultrasilicon, LTPS, oxide, and organic TFT. The main difference among this TFT backplane is the mobility. So far, LTPS and oxide TFT are more suitable for AMOLED for its mature process. Especially for the LTPS TFT, by using compensation circuits, the uniformity issue of display can be solved very well. As for the luminescence part, OLED device is fabricated on top of TFT backplane by evaporation or other processes. It has a sandwich structure with more molecules. In 1987, although the peak EQE is about only 2%, for the first time, Dr. Qin Wen Tao achieved OLED luminescence by using double-layer organic thin film structure. From 1987 to 1997, the improvement of OLED luminescence efficiency has increased from 2% to 25%, which makes the OLED display feasible. As for the controlling part, driving circuit is to transfer external signal to the internal TFT. Mainly, it includes gate driver and data driver, which control the external sequential logic signal and transfer the data signal into the internal TFT, respectively. If we like to talk about AMOLED, we always need to compare it with TFT LCD. Basically, both of them have TFT backplane, luminescence part, backlight plus LCD, and OLED device, and driving circuit. They look same, but actually quite different. TFT LCD uses voltage driving mode, so there is only switching TFT in each pixel circuit. On the other hand, AMOLED uses current driving mode, so it needs not only switching TFT, but also driving TFT. So, the process of AMOLED is several times more complicated than that of TFT LCD, which make it very hard to achieve high yield in mass production. Well, we know it is still not easy to understand. Let us give you an analogy. Yes, both TFT LCD and AMOLED has TFT substrate, luminescence part, and driving circuit. But the difference is just like the difference between an ordinary train and a high-speed rail. You can see that both the train and high-speed rail have the locomotive, carriage, and controlling system. Assuming we can make train easily, is it possible to say we can make high-speed rail? Maybe not. Okay, AMOLED is not easy, but for flexible OLED display, we need to think even more. Usually, the expectations of the consumers and the considerations of the manufacturers are different. From the applicable point of view, the consumer wants the display to be curved. From the technological point of view, the manufacturer needs to think about flexible substrate, ultra-thin, curved, and unbreakable. And the bending radius shall be 15 to 3000 millimeter. The bending time is 1. Then the consumers want the display to be bendable or even rollable. The manufacturer needs to consider thin film encapsulation. The bending radius shall be 3 to 15 millimeter, and it can be bended over 100,000 times. When we talk about foldable, we mean the panel can be folded by one axis. The bending radius shall be 0.5 to 3 millimeter, and the bending time should also be more than 100,000. Finally, real flexible. It can be folded by any axis, even stretchable. There will be no limitation for bending radius and bending times. So, we can see that the key parameters of flexible display are the bending radius and the bending times. According to the above discussion, let's talk about the developing trend of AMOLED display. For product, we need to consider three factors: performance, price, and function. For performance, large size and high resolution like 4K, 8K are always preferred in large size display, and high PPI is also pursued in small size display. For price, mass production yield is always a key issue, and in order to lower the cost, people need to develop oxide activity backplane and solution process. For function, as we mentioned before, the flexible OLED display will probably lead the way, which may develop from curved to bendable, rollable, foldable, and real flexible display with different bending radius and times. Next, let us take some time to make an overview of our Visionox OLED project. We started our OLED project from Tsinghua University, early 1996. In 2001, we founded Beijing Visionox and established the first AMOLED pilot line in mainland China in 2002. After several years preparation, we founded Kunshan Visionox in 2006 and established the first AMOLED mass production line in mainland China in 2008. At the same time, we also started the AMOLED business. We founded Kunshan Display Center, which is called KSIPD, in 2009, and established the first AMOLED pilot line in mainland China in 2010. In 2012, we founded Go Visionox, also called GVO, to move to the mass production of AMOLED, and established a G5.5 AMOLED mass production line in 2014. Now, let us show you more detail. We started fundamental research on OLED in 1997. These are some samples in the very early stage. During the pilot stage of AMOLED, we successfully released the first batch of OLED products in 2003. And also, we developed several samples at the meantime. It's well worth noting that early in 2003, we had already made AMOLED display sample and flexible display sample. For the mass production of AMOLED, we have achieved and kept the #1 shipment record in the world since 2012, and the product region has continuously expanded during these years, including wearable devices like bracelet and kids watch, which is ahead in the market at present. For AMOLED, after set up the pilot line in June 2010, we lighted up the first colorful sample within only 6 months and successfully fabricated the first 12-inch AMOLED TV in mainland China. But what is more important is that we simulated a mass production in the pilot line with a specification as high as possible. Based on what we got from the pilot line, we established the Generation 5.5 AMOLED mass production line, whose capacity is 15K per month. The equipment move-in started in September 2014. After only 4 months, we successfully lined up the first sample in the first mass production trial, which may be a very fast record until now. In June 2015, we have already provided 5.5-inch HD AMOLED module with on-cell touch panel to our customers. If we look through the history, we can find that during these 20 years development, we keep heading towards mass production and always follow the spiral up mode from fundamental research to pilot line and to mass production, not only AMOLED, but also AMOLED. And the key points may be self-innovation, core technology, and long-term persistence. So what will be the next? As we discussed above, we think the flexible display might be the direction of OLED. As shown in this slide, we have developed 3.5-inch, 4.6-inch, 7.6-inch AMOLED flexible display samples in last year. The thickness is around 20 microns, and the bending radius reduces from 5 mm to 3 mm. And what is important is that the process we used is quite compatible with the current one using in our Generation 5.5 mass production line. Now, let me show you something we developed in this year. What you see is a 4.6-inch rollable display. The thickness is 20 microns. In order to make a contrast, we place a coin nearby. The bending radius is smaller than 3 mm. You can clearly see that the panel can be totally rolled up. Well, it works very well after rolling. So, what will be the next? What we have now is the Generation 5.5 AMOLED mass production line with 4K capacitance. It will complement another 11K with certain amount of capacitance of flexible display. In the next step, we will establish a Generation 5.5 or G6 AMOLED mass production line with more capability of producing flexible display. And after that, we plan to set up the mass production line larger than G6. During our OLED development in past years, Visionox highly emphasized the protection of intellectual properties, even from the very beginning in the last century. By August 2015, we have already filed more than 1,400 patents with more than 600 granted. In 2014, we have filed 1.9 patents per working day. Apart from IP, Visionox also actively participates in OLED standard formulation. Since 2002, we have already formulated 2 international, 3 Chinese national standards. And right now, we're also formulating the International Flexible Display Standard, which will be published in 2017. Okay, let us make a summary. Display always develops toward better way of transferring information, and more importantly, human-oriented. And it will be further improved by flexible display with variable sizes or shapes. OLED is not only a prevalent technology in LPD display, but a very promising and feasible technology for flexible display. For Visionox OLED project, we have concentrated on OLED industry for almost 20 years, and we are always targeting the mass production. Until now, our PMOLED has achieved #1 in the world, AMOLED FPD entering into mass production, and AMOLED flexible display heading towards mass production as well. We're always following the spiral up mode, from fundamental research to pilot line and to the mass production. The key points are self-innovation, core technology, and long-term persistence. Thank you very much for your attention. If you'd like to have more information about Visionox, please feel free to contact us. Thank you again.